Hello everyone. This is Dr. R.Sasikumar, Professor, Department of Computer Science and Engineering, RMDEC Engineering College. Today I'm going to take about Booth's recording of multiplier. So what is a Booth multiplication? Normally the Booth multiplication is most suitable for negative number. But by using Booth's multiplication algorithm, we can do both positive and negative multiplication also. But it is most suitable for negative multiplication. So, what is the advantage of Booth's recoding of multiplier means what? We can also reduce the number of required operations in multiplication by regarding the multiplier as the difference between two numbers. For suppose we have a multiplicand and a multiplier. In case a multiplier, if you have a more number of ones, means what the number of steps will be increased. But what is the advantage of both recoding of multiplier means what? Try to reduce the number of steps, and instead of more number of ones, we can use more number of zeros. Okay, so zero means what? No need to multiply anything. One means what? The number of steps will be increased. So this is the way to increase the speed of the multiplication. So it is also called what? One of the fast multiplication algorithm. So how to do that boost recording multiplier means what? In third step, minus 1 times the shifted multiplicand is selected when moving from 0 to 1. Plus 1 times the shifted multiplication is selected when moving from 1 to 0. And 0 is selected from 1 to 1 or 0 to 0. I will give that example. For example, here there are transition, right? So when the minus 1 will come in part, suppose if there is a transition from if there is a transition from 0 to 0. Okay. If there is a transition from 0 to 0, what is the answer? 0. Okay. If there is a transition from 0 to 1, what is the answer? The multiplicand is what? Minus 1. Okay. Right. So that is why I have given right minus 1 time the shifted the multiplicand is selected when moving from 0 to 1. There is a transition from 1 to 0, right? There is a transition from 1 to 0. The answer is what? Plus 1. Okay. Right. So the plus 1 times the shifted multiplicand is selected when moving from 1 to 0. And there is a transition from 1 to 1. The answer is what? 0. Okay, this is the point I have mentioned in third point. Okay, I will give example now. In the table, if 0 to 0, the answer is what? 0. And 1 to 0, the multiplicand is multiplied for plus 1. There is a transition from 0 to 1. That my multiplicand is multiplied by minus 1. There is a transition from 1 to 1. The multiplicand is multiplied by 0. Okay, now I hope you understand this concept now. Now you take one example. We should assume that implied 0 lies to the right of the multiplier. This is an example, right? So in this example, we can add 1 0 extra. Add 0 extra, that is called what? Implies 0. Okay. Now you have to take 2 bits at a time. Now this is what? 0 to 0. What is 0 to 0? In the table represent what? 0. Okay. Then again what? 0 to 1. So 0 to 1 means what? The table represent what? Minus 1. Right? There is a transition from 0 to 1. The 0 to 1 transition is nothing but what? Minus 1. And the third is what? 1 to 1 transition. So 1 to 1 transition means what? 0. So this is 0. Okay. And 0 to 1 transition. So 0 to 1 transition means what? This one will be selected. 0 to 1 transition means what? Minus 1. Okay. So 1 to 0 transition means what? This is 1 to 0 transition. So plus 1. Okay. 1 to 0 transition means what? A plus 1. And again 0 to 1 transition. So minus 1. 1 to 1 transition 0. 1 to 1 transition 0. 1 to 0 transition plus 1. 0 to 0 transition 0. 0 to 1 transition minus 1. 1 to 1 transition 0, 1 to 0 transition plus 1, 0 to 1 transition minus 1, 1 to 0 transition plus 1, 0 to 0 transition 0. This is called what? Booth recoding of multiplier. So what is the advantage of this booth recoding of multiplier means what? Try to reduce the number of steps in the multiplication algorithm. And it is most suitable for negative, both positive and negative, but most suitable for negative multiplication. This is another example. So we have to multiply plus 13 and minus 16. So what is the 13 binary number is nothing but what? I hope you can write the binary value of 13, 1, 1, 0, 1. 1101. So how to get that 13 binary value means what? This is the value. So convert a decimal to binary. You have to do that. So 6 times 6 into 2, 12, remainder 1, then 2 again, 3 2s are 6. So remainder 0, then 2 1s are 2, the remainder 1. Okay, so if the number is lesser than that binary number, yes, you stop the process. And this is the way to write answer. So 1101. And this is positive number. Positive number means what? You can represent 0. Okay, this is called what? A sign bit. Sign bit. Okay. Okay. Now minus 6. So what is the value of minus 6 means what? First you have to take that 6 plus 6. Okay, this is the convert binary value. So 3 2s are 6, 0, and 1 times 1 2s are 2, remainder 1. That's all. You stop the process. Okay, this is what in terms of 4-bit representation 0, 1 1 0. Okay, so this is called what? A plus 6. So plus 6 answer is what? 0, 1, 1, 0. In terms of 4-bit representation, I can add 0. And what is the sign bit? Sign bit is 0 because positive number na 0, negative number means what? Minus 1. So plus 13 and plus 16. But here in the problem, we have mentioned minus 6. So minus 6 means what? You have to take 2's complement. So how to take 2's complement means what? Take 1's complement and add 1 at LSB. Okay, add 1 at LSB. So this is minus. So take 1's complement. Okay, this is what 1's complement. 0 means 1, 1 means 0, 1 means 0, 0 means 1. Okay, so 0 means 1, 1 means 0, 1 means 0, 0 means 1. And the sign bit 0 means what? Here 1. Okay, this is what 1's complement. Okay, and what is 2's complement means what? Add 1 at LSB. That is what 2's complement. So 1 plus 1, 0, and carry 1. Carry 1. So 1, 0, 1, 1. Okay, so this is called what? Minus 6. I hope you understand that minus how to get minus 6. Okay, so plus 13, 0, 1, 1, 0, 1. Minus 6, 1, 1, 0, 1, 0. I hope you understand how to get that value. This is the way. Now, you can, instead of that multiplier, now you can apply that both multiplication. So, both recoding multiplier. So, how to do that both recoding multiplier means what? This is the, this is called what? A multiplicand. Okay. This is called what? A multiplicand. Multiplicand. Okay. And this one is called what? A multiplier. This is called what? A multiplier. Okay. So both recoding multiplier means what? You have to take that both recoding multiplier. What is a both recoding multiplier? 1, 1, 0, 1. 0. So according to that both recoding multiplier, we have to add that implies 0. Okay, implies 0. We have to, this is called what? Implies 0. Now you convert multiplier. So 0 to 0 with reference that previous table, right? With reference to the previous table, there is a 0 to 0 transition, 0. Okay, 0, right? And 0 to 1, we have to represent what? Minus 1. So this is the representation. And 1 to 0, right? 1 to 0 means what? Plus 1. Okay. And 0 to 1 again. 0 to 1 means what? Minus 1. Okay. And 1 to 1, we have 0. Okay. Right. With respect to the table, we have the recoding multiplier 0, minus 1, plus 1, minus 1, 0. So instead of minus 6, you can type that 0, minus 1, plus 1, minus 1, 0. Right. This is what? 13, right? 13. And this is called what? Recoding multiplier. Right? Right? Now, 0 into, and whatever that total number of bits, 5. 5 means what? The product value must be represented in terms of 2n bits. That is the point I have mentioned in that first. So, the Booth algorithm generates the 2n bit product. So, 2n bit product means what? The result must be 2 into n bit. What is the n bit here? Totally 5 bits. So, 2 into n bits means what? The total product must be 10 bits. Okay. Right? So, right, this is what, so the product value, right, 2n bit, 2n bits, okay. And how many bits available? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, totally 10 bits. Now, you multiply 0 into all. This is called what? 13, right? Right? Plus 13. So, 0 into all, 0. And minus 1 means what? Take take 2's complement of 30. 2's complement of plus 30. Okay. So this is what, how to take that 2's complement, right? I'm right 0, 1, 1, 0, 1. How many bits? 2n bits. So the remaining 5 bits will be filled with 0. Okay. Now how to take 2's complement? You take 1's complement, right? So this is what 1's complement first. Okay. So 1 means 0, 0 means 1, 1 means 0, 1 means 0, 0 means 1, 1, 1, 1, 1, 1. And add 1 at LSP. So 1, 1, 0, 0, 1, 1, 1, 1, 1, 1. So totally 10 bits. So 5, 6 ones, double zero, double one. So this is a way to write. So totally 10 bits. So within that bit you have to write. So this one you can remove it. So you can start from here 1 1 0 0 5 ones. Okay, up to this you can write. Minus 1 means what? You take 2's complement of plus 13 and write the bits according to that length. Okay. Plus 1 means what? You write the number as it is. You write the number, positive number as it is. Okay. So, minus 1 means what? Again, you have to take 2's complement. 0 means what? You leave it as it is. Then finally, what? You perform the addition. Okay. Right. This is what? 0. 0 means what? You can, you finally you can perform that addition. So 0, right? You can write 0, 0 plus 1, 1, 1 plus 1, 0 and carry 1. So 1 plus 1, 0 and carry 1. So 1 plus 1 plus 1, 1 and carry 1. 1 plus 1 plus 1, 1 and carry 1. 1 plus 1, 0 and carry 1. 1 plus 1 plus 1, 1 and carry 1. 1 plus 1 plus 1, 1 and carry 1. So 1 plus 1 plus 1, 1 and carry 1. You discard that carry. Remaining you write. This is what 13 into 6, 78. Okay. And this is the result is minus. So minus 78. You take 2's complement of plus 78. You will get this answer. Okay. So this is the way to get final answer. So I will show that answer. So plus 78. How to get the 2's complement means what? This is the way. Right. 3 2s are 6. Then 39. So 0 and 2. 19, 2, 1, 2, 1, 2, 2, so 0, 2, 1, 7. So the final result is what totally you can represent what in terms of totally 10 bits. So 10 bits means what you write as it is 1, 0, 0, 1, 1, 1, 0. So totally 7 bits. So the remaining 3 bits you can represent what 0 because plus 78. Okay. Now minus 78 means what you take a 2's complement. So 2's complement means what first you take 1's complement. So 1's complement, right? So you 1's complement means what? 0 means 1, 1 means 0, 1 means 0, 1 means 0, 0 means 1, 0 means 1, 1 means 0, 0 means 1, 0 means 1, and 0 means 1. Okay. And again, 2's complement means what? You add 1 at LSB. Okay. You add 1 at LSB and 1 plus 1, 0, carry 1. Okay. So 1 plus 0, 1. 0, 0, 1, 1, 0, triple 1. Okay. So this is the answer. We got it. So minus 78. This one is called what? Minus 78. Okay. And this one is called what? Plus 78. So this is the way to perform the both multiplication algorithm. The number of steps will be reduced. That is an advantage of both multiplication algorithm. I hope you understand this concept. Thank you.